So two secants are two chords that either meet on the edge of a circle or outside of the circle. The one outside the circle I think of as satellites that are outside and they have to beam themselves back to Earth so you can see cable or, you know, whatever you're doing with the satellite. And then the ones inside the circle look like the one in the second picture. Does everybody see that they're just two chords that meet inside the circle? Okay? So, there's rules for secants. Now, tangents, if you look at the second picture, are two lines that just touch the outside of the circle in one point, at one point. Okay? So that's what forms a clown's hat. I like to call that triangular part there a clown's hat. Because if you turn it upside down, it looks like a clown's hat. Okay? And there's a rule about that. We're going to learn rules today about the angles. When we get back on Monday, we're going to learn rules about the sides. Some are easy, some are not as easy. So then we've got a third picture, and we have a tangent. Tangents are always outside because they touch at one point outside. So this is the tangent right here. And the secant is a chord. And those can meet either on the inside or the outside of the circle. Do you see how the right guy has a chord going through the field? I always think of a secant as going through the circle and a tangent just skimming the edge of the circle, okay? And there's rules about that. All right, the third one are two secants that intersect each other somewhere in the circle. Now, if they intersect in the center of the circle, we already know rules about central angles and all that. But when they intersect not in the center of the circle, we've got to look at some rules about that, okay? We're going to learn that too. If you look at your formula sheet, down by the bottom, right here, is the rule we're talking about. And it says that the arc above the angle plus the arc below the angle divided by 2, so this arc here and that arc there, divided by 2 will give you the measurement of the angle inside the circle. What are we doing when we're adding two numbers together and dividing by 2?
Averaging.
We're averaging, right? And that's what you do to find out where it is. We know that if it was coming out of the center, it measures the same. But this isn't meeting in the center. Point P is somewhere else in the circle. It's not in the center. You got it? So we do 50 plus 170 divided by 2, which is 110. So we know that this angle here is 110. So I'm going to apologize for this, but I call these the snot bubbles. When you have a toddler and he's really upset and he starts crying like a big bubble comes out of his nose, as it gets outside of his nose, it gets bigger, right? The part inside would be a little smaller because it's contained by the walls of his nostrils, right? So I look at this guy here as being the big arc, and this guy in here is the one inside his nose. Everybody get that?
Yeah.
Well, I'm going to look at my rule sheet, and on my rule sheet, I see two arcs. I see two secants going through on this one right here. You see how that looks like the one we're doing?
Yeah.
And this is all they do. They take the big guy, so that's my x, because that's what I'm looking for, minus the little guy, and divide it by 2, and it equals the satellite angle out here. I'll say that again. The big guy minus the little guy divided by 2 equals the little angle out in the satellite that the satellite makes. It's amazing how this works. That's how they know when to put a satellite in the air and where to put it so that you can get coverage. We can see the Super Bowl or whatever. All right? So how would I start to solve this?
Times 35 by 2.
I would multiply both sides by 2. Very good. And these go away. We get x minus 45 equals 70. So x equals 70 plus 45. And I think that's 115. So that is the angle of x. we already looked at this rule. It's a railroad crossing rule. The two arcs that x creates, 180 plus 52 divided by 2 is 90 plus 26, which is 116. Is that true?
I got 64.
This is one of the snot bubble satellite ones, right? So it's the big bubble, which is 149 minus 79 divided by 2 equals x. So go ahead and put that in your calculator. What is that, 35?
Well, I did it in my head right now.
Well, this is a tangent and a secant. And the last problem there says that the arc divided by 2 equals the angle. That means the angle times 2 equals the arc. I don't like dividing by 2. It's easier to multiply by 2. So 60 times 2 equals 59x plus 2. And that's 120. That's 118 equals 59x when I subtract 2 from both sides. And that should give me 2. X equals 2. So this is a satellite with two tangents, okay? So it's the big snot bubble, which is 25x minus 1 minus, and I need to put this one in parentheses. Why do I need to put it in parentheses? Because I'm subtracting the whole thing, so that minus sign belongs to the 10x and the 11. Over 2 equals 7x minus 1. So I'm going to multiply, I'm going to have 25x minus 1 minus 10x minus 11, because I distributed that minus sign, equals, if I multiply both sides by 2, I get 14x minus 2. Any questions? So now I move, because 2 times 7x is 14x and 2 times negative 2 is minus 2. Now I'm going to get all the x's on one side. 25x minus 10x minus 14x equals 1 plus 11 minus 2. I'm moving all the numbers to the right and all the letters to the left. So I get x equals 10, I believe.
It's 239.
239x. It's number 7 on your paper. So I know that the angle is twice as long as the arc because it hits the edge of the circle like we did the slingshot, right? So we have 240 equals 239x plus 1. Subtract 1, I get 239 equals 239x. So x equals 1. Okay? So, in this case, they give us the angle on the outside on the top, which is 80. They give us the guy in the middle, which is 83. And then they want us to find x so that it'll be true. Well, the rule doesn't change. The problems just move the variables around. So I need to add the two outside ones, 12x plus 2, divide them by 2, and that will give me my 83. Does everybody understand why I put the x where I did? The rule is the outside guys, the average of the outside guys is the inside guy. So I add up the two outside arcs, and I get 12x plus 82 equals 166. 12x equals, what's 166 minus 82? So that's 84. Divide by 12, and that's 7. Somebody check me. So the rule says the big guy minus the little guy, it's a 3, divided by 2 equals 10x plus 5. What is 123 minus 53? So we set it up as 95. The average of the arcs on the outside equal the guy in the middle. So that 7 was a 17. So what is 95 plus 17? Is 112 maybe?
Yeah. It is 112.
112 plus 12x equals, I'm going to multiply both sides by 2, and I'm going to get 24x plus 4. Now I'm going to move the x's to the right. That would give me 12x when I subtract 12. And when I subtract 4, I get 108. And 108 divided by 12, is that 9?
Yes.
X equals 9. So this is a snot bubble 1 again, and it's 171x plus 1 minus the little guy divided by 2 equals the angle in the satellite. Yeah?
Yeah, G.
171x minus 51 equals 122x minus 2 if you multiply both sides by 2.
Oh, it's minus 52, not minus 51.
The plus 1 minus 52 is minus 51.
Oh, I didn't.
All right. So what is 171 minus 122? 171 minus 122. So 49x equals positive 49.
Why is the calculation?
So it's still this big guy is twice as big on a tangent and a secant. The big guy is twice as big as the little guy. So we have to take 6x plus 24 is 2 times the little guy equals the big guy. And that is x equals 11. Everybody see that? Well, when I plug in 11 here, I get 77 plus 13, which is 90. Everybody see that? So what is the rest of the arc?
270.
It's 360 minus 90, which is 270. So the answer to number 12 is 270 degrees, because they don't want this piece, they want this one over here. So there you have the big guy, 3x plus 120 equals twice the little guy, which is 2x plus 120 when you multiply x plus 60 by 2. When I leave the x alone, I move the x over, I get 1x. When I move the 120 to the right, I get 0. When I put 0 into the x plus 60, I get 60 degrees.